All the notes for the first video are available on GitHub on the TD-M11 section. And if you're looking for more details on a section, this is a good place to find it. I've got all the data sheets linked for the audio amplifier, the RF amplifier. I found what looks to be the Bluetooth, or at least the core of the Bluetooth chip on there. And the big one was I got a hold of Honor, and they sent down the data sheet for that in Chinese. And I got that translated to English. Got summaries for each of the sections on OD Master, the manual, the CPS programming, how to correct the prolific chipset, all the stuff that was covered in the first video, but it might be easier to access some of the content. How to program with chirp, and then a full teardown of all the FCC docs. So I spent quite a bit of time on that. Who the agents are inside, and kind of maybe a few discrepancies that are in there, even above and beyond. Looked at all the metadata inside the PDFs to see who else was involved with it. And then at the end we see the links to the different radio package options that are available. So the data sheet came in Chinese, and then I pushed it through a translator, and I got it translated. So it's a Cortex-M0, 64K of flash. And supposedly the developer has tools available in Kiel. I asked them for a copy of that, and they said that they could only ship it to a Chinese address, which I don't have. So we'll see if I can get something from them or not. It's like this was developed in 2022. If you look through a lot of the links on Honor's website, they were pretty proud of their early work on this Cortex-M0, it looks like. So it's a 2.3 volt to 3.6 volt part, which is perfectly matches what we need for the lithium ion. So that should work pretty well. It's a Cortex-M0 core, and we have it in the TSOP20 package on here. Has integrated flash, which is nice, keeps the part count down. And we're looking for this SWD port. So we have an SWD-IO and an SW clock. So I spent some time looking for where that was broken out on the board, and I think I found it. So I'll get some debug tools and see if we can get a hold of this micro. It's got the address space map, which we'll need if we can't find a model for the micro. So this will be very useful. And then a breakdown of the whole memory map and register map. It's probably not enough to fully document the chip, but it's a very, very, very good place to start. It's got an interrupt vector map. It does not appear to have a reset pin that's mapped external. It's a 48 megahertz clock. Has a couple timers inside of it. Some PWM generators, but I doubt are used inside of it. And a single DAC that's mapped to like 10 pins. Because it's the bigger package, it does have a UART available, I think, and an SPI port. I'm not sure if it's being used or not. I haven't fully pinned out the board yet. That was interesting too. It does have a unique ID inside the chip, so we'll see if we can get a hold of that over the SWD port. Here's our pinout for the TSOP20, which is useful when I looked at the test pads to see where everything was going. And we see up here pins 18 and 19, that's PA13 and PA14. I believe that's where the SWD port got mapped. We see this ADC VREF 8 got mapped out to a port, a test pad. So I don't think every pin is used. And I guess there is an external reset right there, pin 4. Also available in two other packages, QFN20 and a SOP16. And so here we've got pin 9's of the VDD pin. Pin 7's been mapped out. And then down here, on pins 19 and 18, we see SW clock and SWDIO, which is part of the SWD port. And those are broken out into test pads, so I'm very hopeful we can get a hold of the micro and dump some memory out of it. See how it's mapped across different pinouts, and we see the down in pins 18 and 19 are the SW clock and the SWDIO, and it is available, of course, in all the packages. So I've got hope. Power configuration for it. So some of the pinouts for the radio from the, what I'm calling the top side, it's probably actually the bottom of the board. But we can see in the top here, pins 1, 2, 3, I think are part of the SWD port. We've got a ground, SW clock, and SWDIO right in here. I originally thought this 4-port pad was at 7, 8, 9, and 10, which also maps down to the micro. Ground, VDD, VREF, and a GPIO pin, PA14. So that turned out to be not go where I thought it went. We've got the speaker connections, that's 25, 26. We've got the microphone, 27, 28. Got auxiliary charge power, 23 and 24, which interestingly enough seem to bypass the onboard USB charger circuit and go directly to the battery terminals. So I labeled them as 23, 24 to BAT plus. It was what it ohms out to. Here on the side of the board, 29, 30, 31 is actually where the side buttons come in. So that's PTT, channel plus, and channel minus. And that board's soldered on and affixed through the ground plane. So 19 and 20 are also ground connections. Got grounds all over the board, just about, obviously where all the screws go through, up around the antenna. It looked like it'd be pretty trivial to put in an SMA style antenna adapter if you wanted to remove the onboard antenna. 5 and 6 appear to be the first click of the switch. So that's how the radio turns on, with 5 and 6. And pin 35 and 36 appear to be the volume adjust. Goes from a 10K to a 1 ohm or so pot inside of there is what it looks like. The LEDs, so 32, 33, and 34. So that's appears to be the error LED, 32. 33 is transmit, receive, or red, green, I guess, depending if you're transmitting or receiving. And then 34 appears to be a bicolor red, green charge LED. I think that covers, there's a couple on here I wasn't able to identify quickly. So pin 11, not sure where it went. It's a little test pad there. And then the other half of the silk screen would indicate this is probably a capacitor, but and one side is ground, 21, but I'm not sure where the second pad goes. That appears to be all the majorly interesting things on this side.